This is gateway number 1 here. I'm going to do all the problems. Hopefully this will help for gateway number 2, and then, if needed, gateway number 3. So, the first one I can just do right on here. There's no special rule here. There's no chain rule, because you don't have like a big guy and a little guy. You just got x raised to a power. So this is similar to if it was like y equals 2x to the 4th. It's just a fraction of negative, so it looks a little more confusing, but it's the same idea. It's just power rule. So you're going to bring down the power, multiply by the number in front. That would give you a positive 5. Reduce the power by 1 and give you negative 5, and then you're not supposed to have negative exponents, so that becomes 5 over x to the 5th, and that's your answer. Alright, number 2 is quotient rule. I'm going to do that on a separate sheet here. So, it is the bottom times the derivative of the top. Now, the derivative of the top is 3x squared minus 8x minus, in big parentheses, and this was something I noticed a lot of people forgot, to subtract this entire part. So this is 2d1 minus 1 d2, and the derivative of the bottom is 20x to the 4th. And that's all over the bottom squared, and you do not have to square that bottom. You can just leave it like it is. But on top, I do need to clean that stuff up. So I've got a FOIL here, which gives me 12 x to the 7th. This is negative 32x to the 5th. This is 9x squared. And then this last one's minus 24x. Minus, and I would keep that big subtraction bracket there still. Distribute in here. So this is 20x to the 7th minus 80x to the 6th. Just seeing a mistake here now. This should have been 32x to the 6th because there was a 5th power and a 1st power there. Over. The bottom just stays like it is. And now I got to subtract what's in the big subtraction bracket. So 12x to the 7th minus 20x to the 7th is negative 8x to the 7th. Negative 32x to the 6th minus negative 80x to the 6th, so that's really plus, and that becomes 48x to the 6th, and then the 9x squared and the minus 24x don't have any common terms over there, so I leave them as they are. And the bottom I leave it like it is too. And then I'm done with 2. So it's regular quotient rule. Just be careful with your powers. I mean, even I made a mistake here with that power. And then be careful with the subtracting of the entire thing here, because that can change this sign and mess up your answer if you didn't do that. Alright, number 3. So number 3 is y equals 5x to the 5th plus 4 to the negative 5th. So this is a chain rule problem. Pretty straightforward chain rule. So I got a big guy here, I got my little guy. So I take the derivative of the big guy. The way I take the derivative of the big guy, since it's a power, is to bring it down and reduce by 1. I leave the inside alone, and then quite a few people forgot to multiply by the derivative of the inside, which is 25x to the 4th. So multiplying, like finishing the chain rule and doing the multiply by the derivative of Mr. Packard, if we want to say it that way. And then you're not allowed to have negative exponents. You can have negative numbers, just not negative exponents. So this 5x to the 5th plus 4 goes down to the bottom and becomes to the 6th power. So I've kind of taken care of that. And then on top, you could have left it like this, or you could have multiplied it and said negative 125x to the 4th. Alright, number 4. So, number 4, part 1, is a product rule scenario. So that's a function of x times a function of x. So h prime would be the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing, and then we got to plug 3 into all those. So I want g of 3 times f prime of 3 plus f of 3 times g prime of 3, and then I'm just getting all those numbers from the chart. So g of 3 is 1, f prime of 3 is negative 1, f of 3 is 3, and g prime of 3 is 0. So then that gives me a negative 1 for an answer. Part 2 is quotient rule. So that's a division. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom. Again, that big bracket helps you remember you're subtracting the whole thing over the bottom squared. So then we're plugging in 4. So g of 4 times f prime of 4 minus f of 4 times g prime of 4 all over g of 4 squared. And we find the numbers. So g of 4 is going to be 3. F prime of 4 is negative 1. Minus f of 4 is 2. G prime of 4 is 2. All over g of 4, which is 3 squared. And then that will give me negative 7 over there. Oops, sorry, you couldn't see that. There's that one. I'll leave it there for a second so you can look at it or pause the video. Part 3 is chain rule. So the big guy is this 2 here. The little guy is your f of x. So your derivative, so h prime, is going to be bring down the 2, leave the little guy alone, reduce the power by 1, multiply by the derivative of the little guy. So then h prime of 2 is 2 times f of 2 to the first power times f prime of 2. So f of 2 is 4. And the first power is just first power. And then f prime of 2 is 1/2. And if I multiply 2 times 4 times 1/2, I get 4. Part 4 is also chain rule. It looks a little different, but we have a big guy here on the outside with the f, a little guy on the inside with the g. So the derivative there, take the derivative of the big guy, you leave the little guy alone, and you multiply by the derivative of the little guy. And then we want to plug in 4. So h prime of 4 is f prime of g of 4. Now that's not a multiplication because there's no x here. We're going to find g of 4. We're going to get that number. And then we're going to do f prime of that number. And then times g prime of 4. So g of 4 is 3. So this becomes f prime of 3 times g prime of 4. And then f prime of 3 is negative 1. G prime of 4 is 2. And if I multiply those two together, I get negative 2. Alright, on to number 5. So this is a product rule. Within that product rule, I'm going to have to use chain rule, because when I take the derivative of this piece of it, I've got a big guy and a little guy. So product rule says the second thing times the derivative of the first thing, which is just 15x to the 4th, plus the first thing times the derivative of the second thing. Well, now I need chain rule. So I'm bringing down the 1/2. I'm leaving the 5x plus 3 alone. I'm reducing the power by 1 and multiplying by the derivative of the inside, which is just 5. Well, now I have negative exponent. I'm not allowed to have negative exponents. So I'm going to bring that down to the bottom. And that's going to get a situation where I'm going to have one fraction and one other thing, which is basically a fraction, but I'm going to need to combine those. So I'm just rewriting this first part over here. And then in this part, I'm going to look at this 1/2 and this 5, and just say, okay, that's 5 halves. So 5 on the top, 2 on the bottom. And then this has a positive exponent, so that's going to go on top. This has a negative exponent, so that's going to go on the bottom. And I can't have, now I got two terms, because I got this big plus sign separating these two things. I can't have two terms, I can only have one. So I need to get a common denominator. Well, the only thing in the denominator over here right now is a 1. So I need to put this denominator over here. I'm going to do it in parts, though. So there's a 2 on the bottom of this piece. There needs to be a 2 on the bottom of this piece. But if I put a 2 on the bottom of this piece, I got to put a 2 on the top of that piece also. And the same idea here. I need a 5x plus 3 to the 1/2 to be on the bottom over here so that it matches up. Well, if I put 1 on the bottom, I've got to put 1 on top. Well, I already had a 1/2 on top. I'm going to put another 1/2 up there. So now if I combine those, you multiply the bases, you add the powers. I really only have one of those up there. So if I simplify this gives me 30x to the 4th. And then I have 5x plus 3 to the first power. Because I added up those powers. Plus, over here, I'm not really changing anything. I'm just kind of rewriting it before I work on it a little bit more in the next step. So my denominators are the same now. I'm going to be able to add these fractions. All I need to do is the algebra and clean up the top a little bit. So distributing here would give me 150x to the 5th plus 90x to the 4th. And I can leave this as 2 fractions for now if I want to. You can shorten this a little bit by skipping this step, but I don't really want to skip steps on this, on the explanation. So this would be 15x to the 5th, and this would be 20. And then finally I can combine them, and there's now 165x to the 5th, 90x to the 4th, plus 20 over 2 times 5x plus 3 to the 1/2. And we're done. So again, that was number 5. And, hopefully that makes sense. Going on to number 6. First thing I would do would be to rewrite this. So this would be y equals 3x to the 4th plus 4 to the 1/3. I am rewriting this because chain rule and quotient rule do not go together well. So I see I need a chain rule here on top. As soon as I have chain rule, I don't want quotient rule involved because I'll get fractions, on top of fractions. So I'm going to bring the bottom up and use product rule instead. So product rule says the second thing times the derivative of the first thing. Don't forget the chain rule piece of it here, so the x to the 3rd, plus the first thing times the derivative of the second thing. So bring down the -1, leave the inside alone, reduce the power by 1, and again, don't forget the derivative of the inside, the chain rule piece. So now I've got this mess, but it's the same idea as the previous one. I can't have negative exponents, so I'm going to flip those to the bottom. And then I can't have these two terms separated by a plus sign. I'm going to have to get a common denominator and add them up. So if I look at this first piece over here, 1/3 times 12x to the 3rd is 4x to the 3rd. And that's actually the only thing that goes on top because those two both have negative exponents, so they will flip to the bottom. And their exponents will become positive. I'll leave some space because I might have to do some stuff there. Negative 15x to the 4th goes on top. This can go on top too because it's a positive exponent. And then this has to go on the bottom, and the exponent becomes positive. So now I have 2 fractions. I'm not allowed to have 2 fractions, so I need to get a common denominator and combine these. So I've got, if I look at the 3x to the 5th plus 1 piece first, I've got 2 of them over here. I've got 1 of them over here. So I need another one of these over here. So I'm going to put another one over there. Now I have 2 of them on the bottom, but if I put 1 on the bottom, I've got to put 1 on the top also, to be fair. So now this is really 3x to the 5th plus 1 squared, which matches up with this. But this piece, I don't have over here, so I'm just going to put it over there. I'm going to put a 3x to the 4th plus 4 to the 2/3 on the bottom. Well, if I put 1 on the bottom, I've got to put 1 on top too, and you'll notice, same thing that happened in the last problem, I have 1 of those now, because you would add up the powers. So, combining this a little bit more. I'm just taking a step and kind of clean things up. So I'm not going to distribute this top yet. I'm just going to go, okay, now this is squared. And I'm going to just kind of show that I do have the same denominator now and clean up the top a little bit. So that's just to the first now. But I have common denominator, so now I will be able to add. So I just need to clean up the top. Well, this would be 12x to the 8th. This would be 4x to the 3rd. Over, and I'm just going to keep writing this stuff on the bottom. And if you're working in your test, and especially when time's an issue, you don't necessarily need to rewrite the bottom every single time. But I also have a slight fear that if you don't rewrite it every time, you're going to forget that it's there, forget something. So this is negative 45x to the 8th, minus 60x to the 4th, over, and just rewriting the bottom again. I definitely don't want to take shortcuts on the explanation. And then I can combine finally and say, okay, now I'm going to put this into one fraction. And combine like terms on top. So I'd have negative 33x to the 8th, minus 60x to the 4th, and then a 4x to the 3rd. That's probably the toughest one, in my opinion. There's just a lot of work, a lot of chances to screw up, a lot of things you got to remember. So hopefully that helps with 6. Number 7. So this is y equals sec of x to the 3rd plus 4 to the 1/2 power. So we got a big, a middle, and a tiny. So my big guy is the sec. The 1/2 is not applying to the sec. So the 1/2 is the middle, and then the x to the 3rd plus 4 is the tiny guy. So I take the derivative of the big guy first. Well, the derivative of sec is sec tan. And what do I do with the little guy? I leave it alone. And then I go on to the next. Well, the next one is the middle. So the middle guy is a power. The way you take the derivative of powers is to bring them down, reduce by 1. I leave the little guy alone. And then finally I get to the derivative of the little guy, which is that 3x squared piece. And then again, I'm not allowed to have negative exponents. But this is all one term, so there's no plus signs like combining terms here, so I don't need to get a common denominator. I really just need to put the negative thing at the bottom. So the 1/2 right there, I can split up and say 1 over 2. 3x squared goes on top. I've done that. This whole thing goes on top because it's all a positive exponent. There's no negative exponents there to bring down. And then that is a negative exponent, so we go to the bottom. And that's it. Yeah, so again, hopefully that makes sense. Great. 2 big issues I saw here. One was you just didn't memorize it, which is, that's just on you. You got to memorize these or you're not going to be able to do them. Second thing is people forgot chain rule. I think you got so caught up in remembering the rule itself that you forgot to do the chain rule piece of it. So the derivative of cosecant is negative 1 over the absolute value of whatever times whatever squared minus 1. And in this case, the whatever is an x to the 4th. So x to the 4th goes here, and x to the 4th goes here. But then you have to do chain rule. So the cosecant inverse is like the big guy, and then the x to the 4th is the little guy. So you got to multiply by 4x to the 3rd. So then you could just bring, like if I multiply all 3 of these together, that's a negative 4x to the 3rd. Absolute value of x to the 4th. You could leave this x to the 4th squared. I saw someone try to make this x to the 6th, and then that caused the whole problem to be wrong because you actually went too far, and if you just left it, you'd have been okay. If you are going to simplify it, a power to a power is multiply. So you'd make that x to the 8th minus 1, but it's also absolutely fine to just leave it like it is. Also absolutely fine if you really wanted to get crazy with the simplifying in this one. X to the 4th is always going to be positive, so you don't need the absolute value signs. So another version of this answer could look like that. It's a little more advanced. You don't really need to do that step. Just kind of showing you what it would be. Alright, number 9. Let me rewrite it so it's a little easier to see. I've got a big, a middle, and a little. So the big guy is the squared. The little guy is the stuff on the inside, which is basically just the e, because the 2 will go away. The derivative of 2 is 0 is what I mean. And then the tiny guy is the 3x to the 4th. So I take the derivative of the big guy first. Bring it down, reduce by 1, leave the derivative of the inside. Then I go to the derivative of the inside. Well, the derivative of the inside is 0 plus, and then the derivative of e to the something. The derivative of e to the something is e to the thing times, that I'm down to like my littlest guy, 12x to the 3rd. And you're welcome to leave it like that. If you wanted to combine the 2 and the 12x to the 3rd, you can. And then just kind of reordering. But this is not necessary. I'm just rewriting it in like the order I prefer, but my preference is not really relevant. Alright. And then number 10 is implicit differentiation. The biggest thing I saw here was people forgetting product rule. So this 4x to the 3rd y squared is a product rule where you got this piece and this piece being multiplied by each other. So it's a variable times a variable, you have to use product rule. So this would be negative 6y squared times dy dx plus, and then I'm putting it in parentheses. I don't need to because it's a plus sign, but it's a good habit to get into because if it is a minus sign out here, you'll have to distribute that through. 2d1. So the second thing is y squared times the derivative of the first thing is 12x squared. Plus the first thing is 4x to the 3rd times the derivative of the second thing would be 2y, but I took the derivative of a y, so multiply by dy dx, and then the derivative of 4x is 4. So these parentheses are completely unnecessary because it's plus. So I'm just going to rewrite it without them, and I'm going to rewrite. I like to put the x's first and kind of clean things up a little bit. You don't have to do this, but it helps me see the problem a little better when I have the number and then the x and then the y. Alright, now I want all the dy dx's on one side and everything that's not a dy dx on the other side. So that's going to stay, that's going to stay, this is going to go over there. So negative 6y squared times dy dx plus 8x to the 3rd y times dy dx equals 4 minus 12xy squared. I'm going to factor out a dy dx, leaving me with those two things on the inside. It's reverse distributive property. And then I'm going to divide by that stuff on the inside so that it cancels over here. And then this becomes my answer. And you could reduce all those by 2, by a factor of 2. But again, you do not have to do that. I don't even think anyone did, and that's totally fine. Alright, so hopefully that helps. If you have more questions, please come see me, and we will do attempt number 2 tomorrow, Friday, November 9th.